Hey guys, Dr. Brown here with Kubo Math, and tonight we're working another differential equation. This time this is a linear first order differential equation, and it's linear on the variable y. Okay, the form, and as we mentioned in a previous video, when you look at differential equations, you're trying to get them into a specific form if you can, so that you have a way to try to solve them. In this case, the function form is dy dx plus p of x y equals f of x. Okay, now I don't know the guy that came up with this, but his pencil was sharper than mine, that's for sure. Okay, he developed a way to multiply this thing by some function, some integrating factor. Now, he called it u of x. Okay, so he said, I'm going to multiply this thing by u, so dy dx times u plus u py equals, I'm going to move this u way out here, u f of x, because I'm going to put something in between. All right, he suggested that if we have some function u(y), and I take the derivative of that with respect to x, I get u dy dx plus y, so the first function times the derivative of the second, plus the second times the derivative of the first, times du dx. If I take that and set it equal to the left side of this equation, u dy dx plus y du dx. Okay. All right, you'll notice there's a u dy dx here and one there. Let's cancel those out. So u py equals y du dx. So in other words, since these are the same, and for this equation to be equal, this has to be equal to that. Okay, I can divide out the y. So up equals du dx. I can separate the variables now. P dx equals du over u. If I integrate both sides, I have the integral, well, let's do it here. The integral of p dx equals natural log of u. Now if I raise both of those to e, I have e to the integral p dx equals, well, this would be plus c1. So this would become c2 u. Now the author said you could calculate what that constant of integration is for every problem, but they said for our needs assume it to be 1. So c2 is 1. So in other words, the integral of the, e to the integral p dx equals u, equals this integrating factor. Okay? So what is that going back up here? What does all that end up telling me? Well, the derivative with respect to x of e to the integral p dx, which is u, times y, that derivative equals u, which is e to the integral p dx times f of x. Now if I integrate both sides, that derivative drops away, right? So now u y equals the integral of u f of x. That greatly simplifies working these problems. So let's work one, okay? What's my problem here? We've got dy dx plus 3x squared y equals x squared. Okay, so step one, you write it in this form. That's step one. Whatever the form is, if you can get it into the standard form for first order diff-E, that's the form, okay? And in that, you can see what is P. Well, P is 3x squared. So step two, P equals what? Now step three is I need to determine my integrating factor. I don't like to call it U, because we use U sub all the time, and I'll U and I'll multiply and I'll have another U, so I have to be careful. But they did call it U. So I'm going to say U equals my integrating factor, and that equals e to the integral P dx, which in this case e to the integral of 3x squared dx. And that equals e to the 3x cubed over 3. So that integrating factor is e to the x cubed. Okay? So that's my integrating factor. Now, step four, I can take and multiply that function, e is that integrating factor times y, and that equals the integral of that integrating factor times f of x, which in this case was x squared dx. All right, well, this is where I'm going to e to the u du, so I have to be careful. Let's let x cubed equal t. T equals x cubed. So dt equals 3x squared dx. So dt over 3x squared equals dx. You can see where I'm going here. I'm trying to eliminate that x squared. So I have the integral of e to the t, x squared times dt over 3, so I'll put my 1/3 out here, over this x squared. They cancel. So that equals 1/3. The integral of e to the t dt is e to the t, so that's e to the x cubed plus c1. So let me bring this guy down. That's e to the x cubed y equals 1/3 x cubed, e to the x cubed plus c1. All right, so that was, we'll call that 4a here. Let's go to step 5. Okay, we're going to work this guy out. E to the x cubed y equals, can you see that? All right, equals 1/3 e to the x cubed plus c1. Now we're going to divide everything by e to the x cubed. So if I divide that here, that's 1/3. If I divide it there, well, as a matter of fact, I'll just divide it here. E to the x cubed equals all of that, e to the x cubed, and that divided by e to the x cubed. So it cancels here. Y equals, it cancels there, 1/3 plus c1 e to the minus x cubed. And that, my friend, would be the equation that differential here came from. And that is the methodology for working a first order linear differential equation. In putting it in, first off, put it in that form. Secondly, identify P. Then e to the integral of P dx gives me the integrating factor. Multiply that integrating factor by y, my variable, and that equals the integral of the integrating factor times f of x. So that integrating factor, e to the x cubed times my f of x. And then go through that integration, solve for y. Okay, why are we doing this? Together we're trying to build a better tomorrow, and do that how? Do that through math. Okay, keep studying, guys. That's all for now, and we'll talk to you next time. Thanks.